How's it going, people? Today we are going to be learning about the unit circle and exact values of sine, cos, and tan, or sine, cosine, and tangent, if you prefer. Now, the first thing that we want to introduce is called the unit circle, and this may be new for a lot of us, so we're going to have to go through how it's formed and what it actually is exactly. So the unit circle is simply a circle that has a radius of 1 and it is on the Cartesian plane with its center at the origin. So you've got your x-axis, y-axis right in the middle. That's where your unit circle, or center of your unit circle is. And then radius of 1. So on the outside, you have point at 1, 0, 1 in the x direction, 0 in the y, 0 in the x direction, 1 in the y is that point up the top, so on and so forth, right around the edge of the circle. Diagram's not perfect, but hopefully it gets the point across. Now, because we're working within our trig topic, we're going to be talking about an angle that we measure from the x-axis, positive side, and we go in an anti-clockwise direction. All right, that is just how the maths convention works. All right. So, once we have that basis, we can start to extend our definitions of sine, cosine, and tangent for angles that are larger than the 0 to 90 degrees that we've been using for SOHCAHTOA and right angle triangles so far. Now, we want to talk about this point anywhere on the outside of our unit circle. So, just simply this point, which I'm going to call x and y, it is x in the x direction and y up in the y direction, okay, and that makes the point xy. Now it has to be less than, or between 0 and 1 for all of these values on the edge. Anyways, talking about our, I'll get this out of the road. If we extend a vertical line down from our point to meet the x-axis, okay, we have a 90-degree angle triangle with theta as our angle. And as we know with 90-degree angle triangles, we can use our SOHCAHTOA rules to get some more information here. So, first thing that we need to know is if we know that this line on the bottom of my right angle triangle is x, and this angle on this side is y, what is the hypotenuse of my unit circle? Well, that is simply from the center to the outside of my circle is the radius of 1. Okay, so if we have a radius of 1, then cosine of this angle, theta in here, just in case my diagram is not clear, that angle in there, then cosine is ca, adjacent over hypotenuse. So the adjacent is the x distance and the hypotenuse is 1, so it's simply the x value. And sine, similar idea, opposite to that angle is y, and over 1 is the hypotenuse. So your sine and cosine are simply the x and the y coordinates of this value up here. So let me write this up here. Cosine theta sine theta. That coordinate there is anywhere along our unit circle, where cos is your x direction, or sine is your y value. Cos is your x value, y is your sine value. So, last little thing that we want to talk about is tan, which is opposite over adjacent. Vector diagram. Opposite is y, and adjacent is x. Y on x. Well, we know that y is sine of theta and cosine theta is x from just what we've just done. So tan of theta is this ratio of, or fraction, sine of theta over cos of theta, and that definition is going to come up quite a bit for us. Now, any point on the edge of the circle can be given as cos of theta, sine of theta, which is your x and your y values. So you really need to get this link between cos is your x, sine is your y, because we're going to use that quite a bit for whether it's positive, negative, etc. Now, before we go any further for our exact values and other angles such as 120, we really want to get a good idea of what these specific values are. These are angles that we're going to focus on. For sine, cos, and tan, we're going to focus on angles 0, 30, 45, 60, and 90. Okay? Any angle that's going to be in this topic is going to be some sort of relationship with these. Okay? And you might have noticed earlier I had labeled in 0 degrees, 90 degrees, 180 is that, 270. I made a small mistake before. So 90 straight up, 180, half a turn, 270, 3/4, and then 360 is right back to where we started, a full revolution. There's a couple triangles that we're going to use to help us get the exact values for all these different terms. Cover that up before I move any further. All right, we have a triangle that has an angle, angles of 60 and 30, which is these two important values. Opposite the 60-degree angle is root 3. You can try and remember that because root 3 is larger than 1. 60 is a larger angle, so it should be opposite the larger side. Okay, 30 degrees is opposite the 1, and 2 is our hypotenuse. Our other triangle that we want to remember is an isosceles triangle where the sides are 1 and the hypotenuse is root 2. Both 90-degree angle triangles, and we've got 45 degrees, which is our middle one here. Right. Pythagoras is working for these triangles. If you were to do it, square root of 1 squared plus 1 squared is the square root of 2, and you can do the same thing for this other triangle here. Alright, so we want to try and combine these triangles, SOHCAHTOA, and the unit circle to try and fill in this table of exact values for sine, cos, and tan of these angles. So let's do a couple, and then I'll ask you to try and fill it in while I get you to pause the video. But first one, for example, let's look at sine of 30 degrees. So go to our triangles, we look at 30 degrees. Sine is opposite over hypotenuse. So sine of 30 degrees is half, and you might remember that from the other videos that we've done before. Okay, but sine of 60 degrees, opposite the 60 is root 3 over 2, and we get those values there. Sine of 45 degrees, opposite is 1, root 2, 1 on root 2. And then 0 and 90 doesn't come from the triangles, we've got to go back to a unit circle. Okay? Remember that sine is your y value at 0 degrees along the x-axis. What is my y value? Well, at the edge of that circle of a radius of 1, my y value is 0. Okay. My x value, however, was 1, which is my cos value. It's keep filling it in. Go back to the 90 degrees. My x value is 0. My y value is 1. So sine of 90 is 1, but cos of 90 is 0. Wasn't anywhere in the x or y direction. Alright, tan's a bit of an interesting one because remember that it is sine over cos, so 0 divided by 1 is 0, but 1 divided by 0 is undefined. Clearly, if you're going to be doing this table, you might want to draw it a little bit bigger than I have. Okay, can't divide by 0, so it is undefined, infinite. See if you can fill in the other details. I'll give you a moment if you want to pause, and then I'll show you the rest. Okay, should be able to do it from the triangles. Alright, well, if you did pause the video and have a shot, hopefully you came up with these values. Alright, and that is the acute angles. Everything that we're going to be doing from here on out is going to use these. And we're going to refer to them as the acute angles because they're between 0 and 90. Although 90 is not really acute, it's right, but we'll get to that. A quick side note that I'd like to make sure that we recognize is that sometimes we have a lot of surds, root 2, root 3 involved in these. Okay. If they are the denominator, occasionally you'll see them written slightly differently because generally maths doesn't like the denominator of a fraction to be irrational. So we want to rationalize it. And the quick way to do that is if I have something like 1 on root 2, if I can multiply this fraction by root 2, I can get an equivalent fraction if I multiply both the top and bottom. Root 2 over root 2 is just 1, so we're not changing it. But root 2 times by root 2 is 2. So now it is rational, and 1 times root 2 is 2. 1 times root 2 is root 2. Same idea with your 1 on root 3. Occasionally you might see it as root 3 on 3. Okay, same values, but you're going to see different things depending where you look. Now, let's talk about angles that are greater than your normal 0 to 90 that we've been talking about. Got to explain this first diagram that I've drawn here. Okay, we are going to be looking at triangles where the acute angle, as I mentioned earlier, is what we're going to be trying to work with, is measured from the x-axis in each of these cases. Okay, now in each of these we have, by the way, these are quadrants. Okay, your first quadrant is where you're in the positive x and y values, and then you go anti-clockwise to label the rest. So you've got 1, both positive, 2, 3, 4. And remembering that cos is your x, sine is your y, can give us a bit more information as to what we might expect for values of sine and cos for each of these, because it's all going to come down to our acute angles. Alright, these triangles that you see, okay, I might try and do them in another color. Alright, those ones there, and those ones there, alright, 4 different triangles, are all congruent. They've got the same width and the same height, but sometimes they are in the negative side of things. So it might be, well, I've got this absolute around the x. It's the same length as this, but because it's in the negative direction, we need to consider whether it is positive or negative, which is why I've got all of these listed around the edge here, and a backronym, which I'll talk about in a second. So in our standard triangle that we've been talking about already between 0 and 90 in our first quadrant, both x and y is positive. Okay, cos is your x, so cos is positive. Sine is your y, so sine is positive. And because tan is sine divided by cos, both are positive. Positives divided by a positive is still a positive. So all of my trig functions, sine, cos, and tan, are positive in the first quadrant. In the second quadrant, all right, we are now on the left-hand side of the y-axis. Okay. If we're left of the y-axis, then our x values are now negative. Same width, but cos is negative, cos being the x. Sine is positive because we're still above the x-axis. Okay. And tan is negative because positive divided by a negative is a negative. Whereas in the next one, both x and y are negative, so cos and sine are both negative. But tan, negative divided by a negative, is a positive. Tan is the positive function in the third quadrant. Just quickly stepping back because I missed it. Sine is the only positive in the second quadrant, which is why we give it S. So we've got A, S, and T so far. And then in the fourth quadrant, X values are positive, but Y values are negative. Cos is the X values, so cos is positive. Sine is the Y values, so that's negative. And then again, a negative divided by a positive is a negative, so cos C is the only positive function in that quadrant there. So if you can remember how to label this, a quick backronym, all stations to central, A, S, T, and C, helps you to remember which of these are going to be positive or negative. So we're going to have a quick, we're going to talk a little bit further about your quadrants, okay? Second quadrant, if you can imagine that the line that we're talking about is this here, it is theta degrees above that x-axis on the negative side, or 180 being the x-axis, a straight line, take the theta, get you to the same place. And so we have a few trigonometric identities here that you're going to see around the place. Sine of 180 take theta is the same as sine of theta because sine is positive in the second quadrant, S. Cos is 180 take theta, so cos is negative in the second quadrant, same x values as what we saw in this, okay? Theta being in this direction, x values, same x direction, but in the negative side here. Similar identities for the third and fourth quadrant, which I won't rush too much into, but the third quadrant is 180 plus that angle, and your fourth quadrant is 360 degrees minus that angle, so you go further back. Alright, so picturing these triangles related to your quadrants and deciding whether they're positive or negative is what's going to help us. Let's run through some examples so you can actually see how it works instead. It's becoming quite a long video. There's a little bit more to go. Alright, find the exact values of the following. We want to determine the acute angle of interest first, and then decide whether it is positive or negative by thinking about our quadrants. So, 150 degrees, what does that look like? A sketch is always going to be a useful thing until you get much more used to how these look. Alright, 150 degrees is greater than 90 but less than 180, so somewhere in here is 150 degrees, okay? Which, from our x-axis, the acute angle of interest is 30 degrees. Okay, sine is positive in the second quadrant, so sine of 150 is the same as sine of 30, and you can go back to your table. Sine of 30 is half, or if you prefer using the trigonometric ratios, you could think about it as sine of 150 is the same as sine of 180 take 30. Alright, but we know that sine of 180 take 30, or some angle, is equal to sine of that angle that we're subtracting, and so it gets us to the same place, sine of 30 degrees, which is half. Alright, so the sketch is going to help when you want to figure out the angle from the x-axis. So again, 225 bigger than 180, somewhere about there. Okay, and note that 225 is the same as 180 plus 45. Alright, so we could do it in the trig identity, or we could recognize that 45 degrees is in here. So we're thinking about cos of 45, but because it is in the third quadrant, the only one that's positive is tan, so this is the same as negative cos of 45, or 1 on root 2 with the negative. Alright, do this again a couple more times. Tan of 210 is greater than 180 by 30 degrees. And there's the 210 degrees, and there's the 30. Now we're thinking about tan of 30, 30 being the acute angle of interest. Tan of 180 plus 30, which is negative tan of, not negative, tan is positive in the third quadrant, so it's just tan of 30. Okay, tan of 30, and I'm going to have to go back to my table to remember what this is. Tan of 30 is 1 on root 3. Positive because it is in the third quadrant. Cos of 270 degrees, okay, 270 degrees goes all around to our negative side of my y-axis. Remembering we're talking about points on this circle. Cos is my x values. How far left or right is this x value here? Well, it isn't left or right at all, so this is 0, negative 1. 0 is my answer here. Okay, here's the x value at the point 270 degrees turn on my unit circle. So some of them, when they're not, or when they're 90, 270, 180 and 270, or 360 degrees, is going to come back to the unit circle rather than our table, I believe is the easiest way to think of it. Now, angles greater than 360 degrees, yes, a little bit more. Alright, 360 degrees is a full revolution, so when you do a full revolution, you just get back to the same place that you started at 360 degrees, and then you might add on another 60. So for example, my sine of 420 degrees, if I do a full loop, then it's going to be an extra 60 degrees left over. So it's going to be the same as sine of 60. They are all positive in the first quadrant. Sine of 60 is root 3 on 2, and it is positive. So the way you can do angles greater than 360 degrees is just keep subtracting that 360 until it is a much easier angle to work with. Try not to go into negatives, although the negatives is our next little thing here, and it can be just as useful to think about. Negative angles is when we're going clockwise instead of the convention of anti-clockwise. So that way is positive, all right? But if we're talking about a negative angle, we're going clockwise from that x-axis. All right. So we could add 360 degrees until it's an angle that we are more familiar with. All right. Or a quick sketch might help you to get to where you're going. So let's look at cos of negative 30. It means we're 30 in a clockwise direction from the positive x-axis. That's already an acute angle, so that's nice and easy to work with. All right, it is in the fourth quadrant, acute angle of 30 degrees. So cos of negative 30 is the same as cos of 30, and it is root 3 on 2. All right. Try not to, as the last little note, work from the angle from the y-axis. All right. You're going to get yourself confused if you're doing that. Always measure the angle from the x-axis. Okay. So this would be fine. Something like this would be fine. But if you're measuring from the y-axis, it's going to cause some issues. Anyways, I hope that helps. Let me know if you've got any questions and see how that goes.